So this is KiCad for those of you that don't know, and really briefly you have your sketch and you have your PCB. These are both different editors here, so if I open this up, you would put in your schematic symbols here. Watch the other video, you'll see what I'm talking about there. And this one here is your PCB editor, which is technically a different program called PCB New. The other one, by the way, was called a schema. Now, if I want to make a footprint, I can come here and I can say footprint library editor. I can go there. If you don't want to make, if you're not currently making a circuit board and you just want to make some footprints, then what you can do is you can just start up PCB New. So what I did is I just went off screen there and just started up the PCB New program. So wherever you've got, if you go to your start menu and you find your KiCad directory, inside there somewhere you'll find PCB New, and then you can just click it, then it starts up. Then you'll come up here and you'll find the one that says New Footprint, load this, and then give it a name that is going to be easy to find when you're searching through all of your different library files. So probably resistor, probably not 10 millimeter resistor. Do you see what I'm saying? Because it'll alphabetize by the 10 millimeter. So we'll go ahead and call it resistor, but I'll give it then, I mean, I think we need to have the length in here at least. You could give it length and width if you like. So you could call it 6 millimeter, but you might want to call it L 6 millimeter or 6 millimeter L or something that denotes that that's the length, unless you've got a real common naming scheme that you're going with. Maybe throw in an underscore there as well. And then after that, then no spaces, by the way. How about 10 millimeter? I'm not going to do a width because it's too small. I don't really care about it. And I'll say 2 millimeter. And you can come up with some secret code, but I'm just going to write spacing. It seems to work for me. So you see what I'm doing? So alphabetically, you'll find all the resistors next to each other. And if you keep the same naming scheme, at least up to about in here, it'll be dash LLLLL, and then you just go scrolling through there looking for the length of resistor that you're after. Go ahead and move this stuff out of the way. We'll place it where we want it later. Okay, then we will add our pad. We need two pads here, two through holes, but we'll add one first because if we make any changes to this one, it'll be easier to modify this one the way we like it and then copy it over rather than have multiples of these and have to take the time to do that to each. So we'll go here to edit the pad, and for the most part, this default one is probably fine. The default one comes out to 0.762 millimeters. Our pin is 0.55 millimeters. So this is all pretty standard. I've noticed through the various libraries that are in the system already, if you look at your basic through-hole components of this same size, they're usually 0.8. So they've rounded this to 0.8. And then over here where the size of the annular ring, the pad, it'll be twice that. So we'll just go 0.8 here and we'll go 1.6 there. I think it's a pretty good idea to just kind of copy what everybody else is doing initially and then kind of make the changes to your liking, I guess, after you've made a few boards. You can look up all the IPC specs on all of this stuff here. As a general rule, what I've read, what I mentioned before, is that the diameter of the hole should be 0.25 millimeters larger than the lead that you're going into there. But I've also read that it gets down into what type of solder are you going to be using because of the different viscosities, right? And so if the gap distance is too little, then you can't get any solder down in there. So another thing, down the road, to be mindful of, not necessarily right now. Go ahead and hit OK. And then we'll want to make a duplicate of this one. You can do a Control-C, Control-V. I'm just kind of used to Control-D for duplicate, and then you can drag it across, click it over there. If you hold down Control F1, that's actually the new, instead of question mark, way to get to all the hotkeys. You can see them right there. Now, I need to make one of these 1 and one of those 2. So I'll click on that. Can you see how it highlights? Make sure you got the right one picked, because if I come over here and I hover over this one and hit E to edit, I'm actually still over on the one on the right. So, well, I guess I could have stayed there. So hit this, and I'm going to change that one to 2 and be done. And next we're going to draw a box around all of this. I'd say zoom in maybe a bit here and try to keep it as tight as possible to where just the actual component will be enveloped inside of here. So I could draw a box around the whole outside here. That's valid. But remember that this part right here and this part right here are just leads. The body of the resistor is inside here somewhere. So you might, I think it might be a good idea to just draw the box right in here like that. And then if you want to tighten this up to make it, even better, tighter, I guess, you could do that so that the actual size of the resistor falls right in there. Let's check it. So I'm hitting escape to drop the tool, pick that line right there and hit E for edit, and it will tell you the position, start stop of all the points of that line. What I'm curious about is the X position. So it's -3. This is a 6mm resistor. That's it. That's the way we want it. So nothing to change there, but that's how you could check if you like. Or you could just know that the grid is 1mm and we're 1, 2, 3 over, you see. Then as we did with the regulator, I think it's kind of a good idea to draw a little line right there and another one right there, just showing that those are connected. And let's move the R value. Then just to save on clutter, I will move this one down here. Remember, this one will be invisible when we place it on the board. Okay. Now, just for the sake of show and tell, not that it's necessary at all, but I am going to do another thing here. So I'm going to drop this down to 1/4 of a millimeter. So we've got a tiny little set of grid dots down here, you see? Then I'm going to take a graphic arc tool, and I'm going to come here to this corner. I'll bring it here and click. You see? So I'm 1, 2 in, bring it up, click, bring it over. 1, 2 in, click, over, round it over. 1, 2 in, click, round it over. Ta-da. There you go. Now, grab your garbage can. You can hit delete on your keyboard, but I find this is a little bit more trustworthy. There we go. Get that. Oh, come on. There we go. And then reconnect your dots. We did kind of the same thing with the regulator. When you're done, you take a look at it, see that you like it. If it's anything like a diode or an IC or anything that has some kind of indication on which direction this is supposed to go, put a little mark on it. Put a dot, put an arrow, put something on here. Remember, though, that this is pretty damn small. And so you do have a limitation on what, size your board house can print, the font size or the line size. I found that they do a really good job. So you probably, don't make things microscopic, but you can put some small lettering on here and they'll manage that, right? But what can you see, right? So there's that issue as well. So you come up here and you save it. If you weren't certain that you picked the active library to begin with, make sure that you do that. Otherwise, it might save it somewhere else that you don't know where it went. And then hit Save Footprint. It'll come back up and say, is that the name you wanted in the library you wanted? Yes, it is. Hit OK. And now we have our footprint. So that is that deal. You can close this down. And now we're back at our PCB editing window. This is where we make the circuit board. So you come over here. You hit Add a Footprint. Understand that this is not normally the way you would do this. Probably not normally the way you would do this. You would typically create a schematic first in the other schema window. You would generate a net list, which is all the components, their names, their associations, values, and what's connected to what. That net list is then read into this, and it puts all those components out here connected, kind of, in the way that they were in the schematic, and then it's up to you to actually route them kind of correctly, I guess. But we're just going to go ahead and place a component, and it's going to be this one right here that we made. So then just double click on it, and you can stick it wherever you want. You could rotate it around if you like. We'll put it right there. So there is our resistor. By the way, notice I rotated around, and so this value here always stays usually upright. You know, there it doesn't know what to do, but you see. Okay, now the big moment of truth. You go here, and now that you've had it placed, you can't do this in the footprint editor. You have to have it placed in the PCB and PCB new. You hit E for edit, and then it has all the values here about that thing. It is a through hole. The pads are locked. You know, you can't just arbitrarily move those around. The value is this. Its name is that. It's on the front. That's fine. What we want is the 3D settings. And if you look right here, this is a mini viewer of the 3D viewer showing you, you know, your footprint. Well, we want to get into this, our 3D shape that we just created. So you go here to add 3D shape, and you have to find it. Now, in my system here, because I'm doing these videos and I want to have it a little bit more concise rather than see just all the crap that I got going on, I mentioned this in previous videos. I keep all of my KiCad projects on my memory stick, and the libraries, the 3D shapes, and everything are stored inside there. So then I can redirect my library location to that memory stick. Every time I'm here and you see like I'm going through the whole tree structure, or you know, it navigates to its default section and then I go somewhere else, that's not the normal way to do it. If you put in everything in its one single KiCad directory and you rewrite your paths to follow accordingly, then it'll just pop right up there. So mine are right here under here's KiCad projects, and then here's my custom 3D shapes. If I hit the drop down here, here is the TO220 package that we made last time. There's that, and there's our resistor. Looking pretty okay. All the colors are there. It does get faceted a little bit, but that's to be expected with a very, you know, round object like this. And then you hit OK. And look at that. Nailed it. So the 1.5 or 1.6 millimeter thickness does seem to be correct. We've got our little solder pads right there. You can see that it fits nicely within the annular ring right there. Not that that's vital. And we've got the leads look like they're bent the right way, you know, I mean the right amount. If I were to have this little tiny, this is only 6 millimeters here, right? And so if I had this resistor in my hand and I grabbed some needle nose here and just sort of bent these leads over, this would probably be a typical, I could see doing that. It's not too tight, they're not hanging out in the middle of nowhere. If you bend the leads way the hell out here, then it doesn't quite have so much support. And, you know, given the fact that everything vibrates, and, you know, the longer you have this, you know, this arm sticking out here, the more it's going to wiggle around. The higher likelihood, believe it or not, that you're going to have that the solder joints or something is going to crack over time. And so like capacitors, anything that's hanging up in the air, you'll want to put some kind of, you know, Celastic or some kind of goop around here, some hot glue to help support it. Could have increased the diameter a little bit there, you see? Or of the footprint itself, so I don't inadvertently stick something too close to this, because if I put another resistor right smack up against there, they're going to run into each other. Let's go fix that. Okay, click on the background so you're not selecting anything else. Hover over something over here, hit E for edit, and We'll hit our top view and zoom in, and that looks much better. So I know that it looks kind of like a fat little like square on the PCB, but we want that, you know, because I mean the distance here, this whole thing is only 2.5 millimeters wide, right? So this thing that looks like, you know, a big square on here, if you put another resistor right next to it because you thought that footprint, you're assuming that the footprint was done correctly. If it was too skinny, these things are going to be very close to each other, possibly even, you know, if you solder them in a little bit crooked, they'll be hanging out, touching each other, which is that a problem? Not really sure. But if one resistor gets kind of hot and it starts heating up another one, then maybe that's a problem. I don't know. Might be being too specific on that. So that is it. But the last thing I want to do is I want to kind of put this all together, what we've learned so far towards our project, or just, you know, if you're watching this in order. I want to place another one of these. So if I wanted to, I could put it here. I could hit OK and bring it around. I could also hit Control D and just duplicate it. Let's check both of these here to make sure. Click on the background first. Hit E. There's my 3D, and I'm sure it's fine here. There's my 3D. So that is all good there. And then these little dudes here, they're going to need to have a regulator. So let's put in our regulator that we had from before. And that's right there. Let's add that in. And so this will go, what are we going to do with this thing here? So we'll place this here, and let's connect some dots in any kind of stupid fashion. So if you want to do this in PCB new, by the way, you go over here. I'll show you first. You go to route tracks and you click on something here and you go, yeah, I want to go over here to over to here to over there, right? And that's how you connect them. If you're doing something with just floaty pads all over the place, you might need to turn off your DRC rules. So let's see, that was input, output. This is going to ground somewhere, so we'll just pretend that's going to ground. And we'll just say that these are tied in series in no particular rhyme nor reason. There, that's a good trace right there. Then you will want to create some edge cuts. So you come over here and you move to a different layer. We have not yet talked about this in the KiCad series, so don't sweat this. You come over here and we'll oops, we don't want to be on, what? Oh, we got to pick a line over here. Here we go. Pick here, we pick there, and pick right to there, clip that off. There is our PCB. So that's the shape. The yellow on the edge cuts here defines what the board is going to look like. Then let's see, we'll have to go here because I've moved the things around a little bit since I've made this one, so I'm assuming that it is not, wow, that was tedious. It's not connected any longer. Yeah, we have no 3D shape for that one. Get to the custom 3D shapes. There is the TO220 package. We'll put that there. You see what I was talking about from before? It lines origins up. So on this one here, what you need to do is just tap the Y forward. I figured out, it's 9.6 to get it about where it belongs. Hit OK, and now that's good. Now, what you can do is you can come up to view, and you can see your whole board propagated with the components on it. So now we're getting there. You can see the traces. We've got all our little resistors there. They're all looking like they're spaced apart pretty well. Flip it over to the back side, and you can see, look at those great solder joints right there. And everything looks okay. The hole from the TO220 is matching up where it's supposed to be. That's it. I hope that you were able to find something helpful in this. I really want to express again the ability to have an object in 3D here really helps understand how your layout's going to go. And for you Fusion 360 people, the CAD designers, I'd really like again to express that, you know, go find a forum somewhere of a bunch of electro nerds out there, or, you know, KiCad or Altium or whoever, people that need these 3D models, and go find some data sheets and practice making some real life products, right? That have a a defined data sheet, not, there's no latitude. You don't get to make stuff up yourself. You have to follow the spec. And then you deliver the goods to the rest of the community and see if it works out for them. I think that is a really good professional skill set to learn. So thanks everybody for watching. I will see you next video.